All right. So yesterday, first part of 7.2, we talked about FOIL. But if you recall, FOIL only works if it's two binomials. Okay? FOIL only works if it's two binomials. If you have anything more than that, anything less than that, it's not going to work. Okay? It's a very specific acronym that only works on those two binomials. So you're going to see some more practice on FOIL stuff tonight on the homework. So just some basic FOIL, just like you did last night. But then we're also going to throw in some new stuff. And the new part is going to look something like this. So we're going to have a binomial and a trinomial. Go ahead and copy that down. Make sure that's down in your notes. So now we can't use FOIL specifically here because we got another term in there. All right, so that's not going to encompass everything that we need to do. So we can't use, there's no fancy word for it, no letters or anything. But the idea behind FOIL remains here. Remember, I showed you after the F and the O, right? The F and the O, we had just distributed that first term to both things here. And then the I and the L, I distributed the second one to both. So really, FOIL was distributed property, right? If you look, I always like this because it kind of looks like an old guy with glasses. Got some hair. Anyway, so we're going to use distributed property. Okay, we're going to use distributed property here. So you're going to take the first term, you're going to distribute it to all three. And then you're going to take the second term, and you're going to distribute it to all three. So you're going to end up with 6 terms that you're listing out. And then you got to combine your like terms. Okay? So I want you to do that. I want you to take the x, I want you to distribute it to everything. And then I want to take the positive 4 and distribute it to everything. Go ahead, try it out. Let's see if we can do it. Okay, talk to somebody about it. See what they have. The negative 2, that's just going to be negative 8. Not negative that, right? Only taking 4. That's second line here. 12x squared plus 20x. So change that to here and take that x away. Because you're only taking that 4 times x. Right? 4 times 3x squared is not, we're not magically going to change that to x to the third. say x squared. I think what you do, yeah, you just sort of got those answers and then find all those. We need 6 specific terms. Forget about those 3 more. All right, so let's take a look. Okay, we stumbled across a common mistake that happens here, and when people distribute the x, but then they try to distribute the 4 into those answers. We need to have 6 specific terms, 6 new terms, individual terms on that second line. So we're going to take that x and we're going to distribute it to all 3. So if I take that x times all 3, we did this yesterday, all right? X times 3x squared is 3x to the 3rd. X times 5x is 5x squared. X times -2, -2x. You're just adding an x on the end of everything. And if it already has an x, then you're adding 1 to the exponent. Okay, so that's taking the x to everything. Then I'm going to take a 4 to those same 3 terms. I'm going to take the 4 to 3x squared. So 4 times 3x squared is 12x squared. 4 times 5x is 20x. 4 times -2 is -8. Right? So I'm taking those x's to these 3, and then I'm taking the 4 to these 3. So I'm going to end up with those 6 different terms here. Then what I can do, then I can combine my terms. Okay? I only have 1 x to the 3rd, and remember, it's got to be standard form, so I'm going biggest exponent to smallest. I've got a couple x squareds that I got to combine. I've got 2 x's, so -2x plus 20x. That's going to give me plus 18x. And then I've got that minus 8 at the end. So that would be my answer for it. The more terms we start multiplying together, the bigger our answers are going to be. Right? Yesterday, our answers were trinomials. We had 3 terms in our answers. Right? Now we've got 4 terms in our answers. The more stuff we're multiplying, the more terms our answer probably is going to have. Okay, any questions about this example here? Okay, so let's try another one. Same idea. Okay, go ahead, try those, or try that one. Remember, when you're distributing, you're multiplying those numbers together. Careful of your negatives. Okay, talk to somebody about it. Yeah, make sure you got the same thing. If you don't, figure out why. All right, here we go. Let's take a look. So I distributed the 2x to everything. And then the next time I distribute, what am I distributing to those three? Okay? A -4. You got to take the negative with it. Okay? That is a -4 that I am distributing. So -4 to all of these, which means that's minus 32x squared plus 20x minus 40. Okay? If you don't take that negative with it, you are going to get it wrong because that is a -4 that we need to distribute. Okay? We can't lose the negative. So then we end up with 16x to the third. Combine those to get a -42x squared plus 40x minus 40. Did we get that? Yeah? Excellent. Good deal. Any questions on our distributive here? Now we could do this with any number of terms, right? If I added a third term on here, then I just take that third term and I distribute it to all three. We're really not going to see that, but we could do it. Okay. All right. Talk to the person next to you, figure out how you're going to do this. Figure out how you're going to do it. Talk to somebody. Once you have a game plan, go ahead and try it. Let's see what we can do. I will tell you, you know how to do everything you need to do. So there's nothing new here.
I don't know. I think it's confused. It's confused. Hold on.
I know a lot of you guys are on the right track. But let me just say, you cannot multiply all three together at the same time. Okay? You can't do all three together at the same time. Turn and talk to somebody from a different table. See if they ended up doing the same thing as you. All right, here we go. So I don't want an answer yet. I want to know, how did you do it? So what process did you do? Did you and your partner decide to do here? Levi?
We took the first set of parentheses and we multiplied, distributed that to the other two.
So you took this and distributed it to both of these? Okay. All right.
I distributed the first two things, and then I used the answer for that and distributed the last two numbers for it.
Okay. So you multiplied these two together first.
Yeah.
And then took this one into it.
Yeah.
Okay. All right. Cool.
After you distribute the first one of the parentheses to all the others, the two other parentheses ones, we just add them together.
Okay. So you distributed, sort of like Levi did, distributed to here, and then combine like terms. Okay. Anybody else? Yeah.
I did the first one, like, times the second one.
Uh-huh.
And I did the second one times the third.
So you multiply these two together.
Yeah.
Multiply these two together, and then what'd you do?
Like,
Combine like terms.
yeah.
Okay. Yeah. So let's think of this as a simplified version. Okay. Let's think of this as, actually, let's do this. Easier numbers. 2 times 4 times 6. Okay. I want you to think if whatever you decided to do is going to work for this. If you multiply to both of these, is that going to give you the same answer? Right? Because right now, this is 2 times 4 is 8. 8 times 6 is 48. Right? If I multiply this times this, and this times this, does that give me the same thing? So I can't distribute here to here and to here. I can distribute it to one of them, right? If I distribute it to one of them and then multiply it by the other, I'm going to get that 48. So what that means for us is we got to combine 2 of these first. And it doesn't matter which 2, but we got to combine 2 of them first by foiling. We're going to foil first, and then we're going to use what we did today. Okay? So if what you did isn't correct, perfectly okay. This was a learning experience. Just make sure that you scratch that out or say not right or something like that. And make sure you put the right version down as we do this. So we can foil the first 2. It doesn't have to be the first 2. It could be the last 2. It could be the first and the last. Doesn't matter. I'm going to foil the first 2. So I foil them. X squared minus 7x plus 8x minus 56. Combine my like terms. I end up with x squared plus x minus 56. Okay, that's the first two multiplied together. I still need to multiply by that last one. Now I'm going to distribute. Okay, now I'm going to do what we were doing over here. Doesn't matter that the binomial is after or before, we can still do the same thing. So you could either take the x squared, distribute, the x and distribute, the negative 56 and distribute. Personally, I would just take the binomial and distribute just like we've been doing. So take the x to everything and then take the 6 to everything. The x to everything is going to give me x to the third plus x squared minus 56x. And then the 6 to everything is going to give me an 6x squared plus 6x minus something big, 336. Right? Is that right? 336? Okay. And then combine your like terms. So we end up x to the third plus 7x squared minus 50x minus 336. All right. Great. Any questions about that one? Okay. You will see one in the homework like that tonight. Okay. FOIL first, then distribute. We're going to look at one more problem, then we're going to be done. All right, talk somebody figure it out. I want the area of the green sections. It's a shaded section. Talk somebody figure it out. I'm going to give you 2 more minutes to try to figure this out, then we're going to talk about it.
Did you say the green part of it?
I can measure this, but the green part and the white part.
They're the same. Oh, wait.
Or if you're using All right, here we go. Here we go. All right, tell me, what did you do to find the answer? What did you do to find the answer?
I distributed the x plus 6 to the x plus 5 and then simplified and divided by 2
Okay, why did you divide by 2?
because the white part and the green part are equal.
Yeah, the white and the green are exactly the same, right? It's exactly the same. If you take this white triangle, you flip it, you put it here, that takes up half of that rectangle. Okay, takes up half. So that's probably the most straightforward way that we can do it, is to find the area of the whole thing and then cut everything in half. That would be x plus 6 times x plus 5. We're foiling. First, outer, inner, last. 5x plus 6x plus 30. Combine your like terms. But then, as I said, we got to divide everything by 2. We got to multiply by 1/2. So I'm dividing everything by 2. That's going to give me 1/2 x squared plus 5.5x plus 15.5. If you want to use decimals, that's fine.
That'd be 15.
15. Just kidding. I got so used to writing a half, I just felt like writing a half in there. Plus 15. Thank you. Makes more sense. Okay, so that would be our answer. The other way that we could do this, if we don't realize that it's simply half, or let's say the triangle isn't half, is we would have to find the area of the whole thing. And again, the area of the whole thing was x squared plus 11x plus 30. And then we would have to find the area of the triangle and then subtract it. Okay, so we would find the area of the triangle, which would be 1/2 times x plus 6 times x plus 5, which is exactly what we just did here. All right, the area of that triangle is 1/2 x squared plus 5.5 x plus 15. And then I'd have to subtract them. But we know since it's exactly half, that's going to be our answer. Okay. So anytime you see a problem like this, you can find the area of the whole big thing, find the area of the white part, and subtract it. All right. Any questions about today? Perfect. Go ahead.